Let's talk about domain. What is a domain? Your what values? Your x values. All right? It's basically what x values can we put into a function to make it work. All right? Sometimes there's restrictions on it. For instance, if it has a fraction. If it has a fraction like this first example, I have 1 over x squared minus 4. What can we not divide by? What are we not allowed to divide by? You can't divide by 0. All right, a number over 0 is actually an asymptote. And so we have to talk about those restrictions on our domain. So basically, when we have a fraction, we set the bottom not equal to 0. So I set x squared minus 4 not equal to 0. And then let's go ahead and solve. Well, this one does factor. I'm going to actually do it by factoring. What can we factor x squared minus 4? X minus 2 and x plus 2. So that cannot equal 0. So x cannot equal 2, and x cannot equal negative 2. So those are my domain restrictions. It can be everything else except for that. Now, I am going to write this in interval notation. And so what is the furthest left a number can be? Does anybody know? Negative infinity. So I'm going to go from negative infinity to negative 2, because that's where my restriction is. And then I'm going to go from negative 2 all the way to 2. And then I go from 2 all the way to what? What is my furthest right it can be? Positive infinity. So my domain is right here. Okay? Now let's think about a square root. What can you not do in a square root? What can you not perform in a square root? Because we're in a real number system. You can't have a negative number. All right? So what we do in a square root is we take its radicand, what's inside the radical, and we make it greater than or equal to 0. In this case, x would be greater than or equal to 0. And if I were to put it in interval notation, I start out with 0, but how do I include 0 on interval notation? Do I have a parenthesis or a bracket? It would be a bracket. So now I have 0 to infinity. On A, I have a bunch of ordered pairs. And I need to figure out the domain of that. All right, so domain mostly works with my what values? My x values. So my domain of this function would just be my x values of those ordered pairs. So in this case, it would just be what? Negative 3 and negative 1 and 0 and 2 and 4. Okay, so it's just those specified x values when they have a list of ordered pairs going on. If I were to ask for the range of ordered pairs, it'd just be a list of the what values? The y. All right, let's look at B. What does B have going on? It's a fraction, right? So when I'm talking about domain, what do I need to do with the bottom of a fraction, the denominator of a fraction? Set it not equal to 0, exactly. All right, so now I'm going to have x plus 5 does not equal 0. And so when I solve for x, x cannot equal what? Negative 5. So what is my furthest left value? Negative infinity all the way to negative 5. And then I go from negative 5 to infinity. All right, this next one. I have volume of a sphere. Okay, the great thing about wearing masks is that you don't spit when you say sphere this year. All right, if you do, it's just going to be caught by your mask. So, volume of a sphere. What needs to happen on my inputs of a sphere? My domain's going to deal with my radius here. What kind of radius could I have to find a volume of a sphere? It has to be a positive number because your radius has to be more than 0, right? So I basically have 0 to what? What would be my furthest radius? Infinity. All right. Why can I not include 0 here? I have a square root again. What can we not have in a square root? A negative. So I'm going to set my radicand 4 minus 3x, and what do I have to set it? It can't be negative, so it's greater than or equal to 0. And then we're going to go ahead and solve. All right, there's many ways to tamp on here. Do you want to subtract 4 or add 3x? It doesn't matter to me. Which one you want? Add 3x. So now we end up having 4 is greater than or equal to 3x, and then we divide by 3, so we get 4/3 is greater than or equal to x. Now, I need to put this in interval notation. What is the least value I can have? Negative infinity is my least value. Can we ever include negative infinity? So we have a parenthesis, and then comma, 4/3, and then what? Can I include 4/3 here? Yes, so that's why it gets a bracket. All right. Now, just to check it, pick something that you made here. So pick 0. Is 0 on this interval? Yeah, so if you have 4/3 is greater than or equal to 0, does it work? Yes, okay, so a common mistake I see here is that they go like 4/3 to infinity, and they kind of have it backwards a little bit. So just kind of substitute in a number that you think's on the interval, and so I'm going to say, I don't know, x plus 3 over x squared minus 16. No, that's too much. Let's do 25. All right, so let's say I have this function. Let's say I have that function. What kind of function do I have here? I need to find its domain. I have a fraction. What do we do with fractions? Set the bottom not equal to 0. Exactly. So I'm going to set x squared minus 25 not equal to 0. And this one's factorable, so I could have x minus 5, and then x plus 5 does not equal 0. So x cannot equal what? 5, and x cannot equal negative 5. So now when I write it in interval notation, this would be negative infinity to what? Negative 5. And then it goes from negative 5 to 5, and then it goes from 5 to infinity. All right? Did I ever mess with negative 3? Did I ever take the top and set it equal to 0? No. Is the top allowed to be 0? Yes. But is the denominator, the bottom of a fraction, allowed to be 0? No. All right? I have a baseball player in here, don't I? Who's my baseball player? Eric. Eric, read for me, please.
The baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second and an angle of 45 degrees. The path of the baseball is given by the function f of x equals negative 0.0032 x squared plus x plus 3, where x and f of x are measured in feet. Will the baseball clear a 10-foot fence located 300 feet from home plate?
All right, will it? How do I find out? It's actually real simple. How do I find out? What's x? When I have a function, guys, you have a function that kind of goes out like that with coordinate axes. You've been doing it for a long time now. What does x represent? My what distance? Horizontal, right? And f of x represents my what distance? My vertical distance, all right? So that would be my f of x, right? So if it says 300 feet from home plate, which one is that? It's my horizontal distance. And then this 10-foot fence would be my what? My vertical distance. All right, so all I need to do is substitute in what? 300 in for x. So now I need to find f of 300. F of 300, what do we got? We get 15. So we got 15 feet. When it went out 300 feet, it is 15 feet in the air. Did we get a home run? Did Eric get a home run? Yeah. Yeah, we got a home run. All right, so yes, it will clear. So now we have domain and range given a graph. All right, so this will be on your quiz as well. So we have a graph. And domain deals with my what values? My x. And range deals with my what values? My y. All right, so I need to find the domain of f. So what x values am I allowed to have on here? What's it go from? My furthest left goes to what? -1. Do I get to include -1? Yes. So what do I need on it? A bracket. And then what's my furthest right x value? 5. Do I get to include 5? No. So what needs to happen? It has a parenthesis. So there's my domain of that one. All right, let's look at part B. Now I need to find f of -1. You know what? Where's the board point? Who came up with function notation? I'll give you a board point. Euler. Yeah, Leonard Euler. All right. All right, Elijah gets the board point. All right, so f of -1. Well, what is it? What is my y value at -1? 1. And then f of 2. So what is my y value at 2? -3. All right. And now we're going to talk about its range. So what is my lowest y value? -3. Do I get to include it? Yes. So how do I show that I include it? I use a bracket. And then what's my highest y value? 3. Do I get to include it? Do what? Yeah. So I show it with what? With a bracket. All right, here we go. This is a vertical line test. And a vertical line test, we kind of hinted about it the other day. A vertical line test tells me if it's a function or not. All right. So, is a function? No, a is not a function. B, is b a function? Yes. Is c a function? Is c a function? Lucas? Yes, it sure is. So a lot of people say no on that one. And did it cross twice on that one? No. All right, it just didn't have a domain from 0 to 2, not including those. And that's okay. This would be called a piecewise function. Remember that term? All right, so that's actually a piecewise, but it's still a function. So now we're going to find zeros of a function. Zeros, x-intercepts, and roots all mean the same thing. They are synonyms of one another. All right. Well, we talked about x-intercepts before. What did we do when we found x-intercepts? We substituted 0 in for y because the x-axis is known as what? Y equals 0. All right, so all we're going to do is we're going to set all these equal to 0. So now I have 0 is equal to 3x squared plus x minus 10. Well, what do we do to quadratics? We F them up. We F them up. So now we end up having quantity 3x, x. Now how do I get my other terms? I need a positive 1 in the middle, and I got a negative 10. All right, so we get 3x what? Minus 5, and then x plus 2. Did we still get to Tampa, guys? All right, good. All right, so now I'm going to use the zero product property, and so then I end up getting x is equal to 5/3, and x is equal to -2. However, this is asking for a 0 or a root or an x-intercept. So what do I need to make them in? Because right now I have freaking lines. I need to make them into ordered pairs. All right, so I don't have to take half off on your quiz, and then I waste my ink, and then I have to buy more pens, and that'd just be terrible. All right, so then I have ordered pairs for my x-intercepts or zeros. This next one, I have the square root of 10 minus x squared. So, to find a 0, I just set it equals 0. What do I need to do first? I need to get to x. What's the inverse operation of square rooting? Squaring. So now I square both sides. All right? So now I end up having 0 is equal to 10 minus x squared. And then what? I add x. And then what? I square root. But when I square root, what happens? I get a plus or minus square root 10. All right? So how many do I have going on there? I got 2, and I need to make them into ordered pairs. So now I have a negative square root 10 comma 0 and square root 10 comma 0. All right, pretty good in the hood? All right. This next one, again, I'm going to set it equal to 0. However, when I do that, my first step is to multiply by t plus 5. And when I do that, I got 0 times t plus 5. What happens to t plus 5? It goes away, right? It goes to 0. So really, all I'm doing is setting the numerator equal to 0. So now I have t minus 3, or 2t minus 3 is equal to 0. All right, because technically I'm multiplying right there. And then these kind of go away. They go to 1. And then these guys go to 0. So now I have 0 is equal to 2t minus 3. So then t equals what? 3 halves. However, that's a line still. So my ordered pair is 3 halves comma 0. Write those out. For domain, if it's a fraction, for domain, if it is a fraction, what do? You set the denominator what? Not equal to 0. If it's a square root, what do? You set the radicand what? Greater than or equal to 0.